Hi everyone, I welcome you to the presentation of this lecture, force resolution. The previous one was a presentation of force resolution where we're dealing with three forces acting at a point, and we used the rule which we're calling the maze rule or the triangle rule. This time around we're looking at the number of forces which are more than three. If they're acting at a point, how do you resolve them? So we're going to look at the component form. So when several forces act at a point or the resultant of the forces can be found by determining the horizontal as well as the vertical components, which are, for example, you may have this x-axis and the y-axis like that. Then from the origin there, you've got forces acting. You've got force, let's call it force 1, acting at an angle which we can call theta 1. We have another force there, force 2, which is acting at an angle which we are calling theta 2. We may have another force there, force 3, acting at an angle which we can call theta 3, and we've got another force there, force 4, an angle there which we are calling theta 4. So I want you to note that the angles, I'm taking them from the positive x-axis to where the force is. All the angles have been measured from here to where the force is, like that. So this is what you should be doing when you're given a question. Make sure the angle starts at the positive x-axis, then it goes to where the force is. That's when you'll be able to use the formulas I'll introduce soon. So if you have this, then the components, we have two of them. We've got the horizontal component as well as the vertical component. So you're supposed to find, each force has got the vertical and the horizontal component. So find the horizontal components for all the forces, add them, and the vertical components for all the forces, add them. So horizontal components or total horizontal component is given by the force times the cosine of that angle. Mind you, the angle is from the positive x-axis to where the force is. So for this force 1, you get this force cosine of that angle from the positive x-axis to where the force is. For the second one, which is this one, you get the force which is force 2 and the angle from the positive x-axis to there. For all of them, you do that, you're going to have this. And then you can also find the vertical components. Vertical components are just like the horizontal components, except instead of the cosine, you use the sine, but the principle is the same. So you find the total vertical and the total horizontal. Once you find that, then it's easy to find the resultant of the forces. So the resultant is given by, you square the total horizontal force and total vertical force, add them, and then you find the square root like that. And then you need to find the angle at which that resultant force is acting. So the resultant force acts at an inverse of total vertical components divided by horizontal components. Let's look at some examples. So this example, I got it from one of the TVETA past paper questions. It was a B part of the question. So it was saying 5 coplanar forces act on an object as shown. So these are the forces. We've got this force, this force, and that force there. They're acting and the angles are there. Calculate the resultant force Fr. So for us to calculate that, we'll do what we did, except if you look at the angles, not all angles are coming from the positive x-axis. So we're supposed to find those angles from the positive x-axis to where the force is. So x-axis is there, and there we had a force 80 newtons. Obviously, it's acting at 0 degrees because it's in the x-axis. Then we've got another force there, which is 100 newtons. It extends an angle of 50 degrees from the positive x-axis. And we have another force there, 50 newtons. That 50 newtons extends an angle of 140, because we know this x-axis is 180 degrees up to there, but they've given us a 40 there. So for us to find the angle from there to there, just subtract 180 minus that 40, you're going to have this 140. We have another angle there, another force there, which has a magnitude of 85. Its angle from the positive x-axis, it's easy. We know that from here to there, they've given us 75. And we know from here to there, it's 180. So we can add 180 and 75. We're going to get that as the angle there, 225. Okay, and then we've got another force there, which is the last one. The magnitude of the force is 70 newtons. The angle from there to there, they're saying it's 70, but with my formula, we are getting angles from the positive x-axis to where the force is. So this will be 360 minus 70 degrees, and this one is going to give us 290 as the angle. So with those magnitude of forces and the angles, we can now apply those formulas we discussed in the previous slide. So total horizontal forces It's basically given by those. Since we have 5 forces and angles, these are the ones from F1 all the way up to F5. We'll substitute, we're getting that, put this in the calculator, we're getting 69.8 newtons as the total horizontal component. Total vertical component is the same, we're just using sine. When you're fusing those, put in a calculator, we are getting negative 17.1 newtons. And then for us to find the resultant force, it's basically you square those and then you square root them. After adding them, we are getting 71.9 newtons. For the angle, resultant angle, it's basically an inverse of the vertical over horizontal. When you do that, we're getting that as the total, as the angle for the resultant force. So instead of you having all these forces acting at different angles, you can just have one force of that magnitude, let it act at that angle. Negative means you are going in the clockwise. So you're measuring 13 from here to 13, maybe somewhere there. And then it's going to have a magnitude of that. So that one force will have the same effect as what all these guys are doing. Thanks for watching.